lesson of chapter 11. So we have a test next week. That's something you want to keep in mind. It is about a lot of things and a lot of formulas, of course. So having a very good note card is going to be clutch. All right. Hopefully a lot of the formulas you've memorized. Base times height comes up a lot. 1/2 base times height. Trapezoid is the hard one. Circle, circumference, like all sorts of stuff that we've done. So this has been quite a unit. So this is the last section today. All right, and we talked about scale factor yesterday. And yesterday we said that if we have linear measurements, and what were linear measurements? What's a length, height? Yeah. Length, radius, diameter, height. These are all linear measurements, all right? And so it's important you realize it's units to the first power. Those are all linear measurements, and they determine our scale factor, which we said was A to B if we have similar solids. And if we want to figure out surface areas, what do we have to do? Since that's area, what do we have to do to their scales? Square them as well. Area was always units squared. And so we have to do the same thing to their scale factors as well. I'm not recording, am I? Oh, I am. Okay, good. And so we have to do A squared to B squared. And then volume is cubic units. And so, again, when we're talking about enlarging or shrinking something, increasing its volume or shrinking its volume, we have to do the same thing to their scale factors. So A cubed to B cubed. And so some important things we're going to do here. We want to make sure that we always reduce the ratio. And then if we're given surface area or volume, we need to go back to that A to B scale factor first before we can go and do what's asked. So we always need to go back to what's A and B. So, number one, if the cones below are similar, so that's very important. I know that they're similar. What is the ratio of the surface area of the larger cone to the surface area of the smaller cone? All right. So what information are they giving us in the picture? The slant height. So these are linear measurements. They're just yards to the first power. And so I know that I have 28 yards over 8 yards since they're similar. And those reduce. What can we reduce those to? 7 over 2. So you divide it by 4. All right. So we can divide by 4, top and bottom. That gives me 7 over 2. And what is that in my little factor ratios here? A to B. They are the scale factors. That's our A and our B. All right. And so if I want the ratio of the surface area of the larger cone to the smaller cone, what do I have to do with those? Square them. So 7 squared to 2 squared. That's the larger cone. And then the smaller cone. So 49 to 4. We have to square A and B, and that's all we have to do. Let's look at number 3. If the cylinders, are below are similar, very important, they must be similar. What is the ratio of the radius of the larger cylinder to the radius of the smaller cylinder? All right, what information have they given us? They've given us surface area. So it wants the larger to the smaller, so I'm just going to start with the larger. So 116, and again, this is millimeters squared over 29 millimeters squared. Oops, that's a typo. It should be squared, not cubed. That's not one I'm familiar with, so I'm going to jump to my calculator. 116 over 29. Oh, look at that. It's, who knew? It's just 4. Well, all right. So what does that reduce to then? 4/1. Very good. So this is 4/1 millimeters squared to 1 millimeter squared. Okay. So what information is the 4 and the 1? Is it just A to B? No, they're still squared. Yeah, so it's the surface areas. So it's A squared over B squared, okay? Again, the millimeters are squared, and that's important. You know, that's kind of nice to help you remember, all right? All right, so if 4 is equal to A squared, what's A? 2, And if 1 is equal to B squared, what's B? 1, okay. And so we just want the ratio of the radius. Radius is a linear measurement, so they just need 2 to 1. So maybe I'll write that in. That is the linear measurement. So we just needed the A and the B. All right. I think that, oh, let's do number 5. Number 5. The pyramids below are similar. What is the ratio of the volume? So if we want the ratio of the volume, what am I looking for in terms of scale factors? Cubes. A cubed to B cubed. Yes, that's what we're looking for volume. Of the smaller pyramid to the volume of the larger pyramid. Right now they're giving us surface area. So smaller to larger, I would say I'd write 52 inches squared over 325 inches squared. What do I need to do? Reduce, absolutely. And these are numbers I'm not too familiar with. Divided by 325, and I'm going to math bracket, and it becomes 4/25. So that is 4 inches squared over 25 inches squared. Okay, what information is this in terms of scale factors? It's squares, yeah. It's A squared and B squared here, all right? So if 4 is a number squared, what's the number? 2. And if 25 is the number squared, what's the number? 5. So we always have to go back to A and B first. We have to figure out our A and our B. Now, all they want is the ratio of volumes. So that's A cubed, so we're going to have 2 cubed to B cubed, which is 5 cubed. Or what is 2 cubed? 8 to 125. So that's the ratio of their volumes. You'll notice they wanted it smaller to larger. We got the smaller number on the first and the larger number last. That's the order they want it in. Does that make sense to you? Okay. Okie dokie. Turn the page. Last page. So here's what we're really doing today. Let's look at number 7. The ratio of the diameters of 2 similar cylinders. So they are similar. And we've got ratio of diameters. And diameters is a linear measurement. It's like inches or feet or yards. Okay, that's linear. So what are they giving us here with the 3 to 5? A and B, yeah. So A is 3 and B is 5. That's what they're giving us. If the surface area of the smaller cylinder is 378 square inches, find the surface area of the larger cylinder. All right, I need the surface area of the larger cylinder. I don't know what that is. I'm going to call it X. If I'm trying to find surface areas, what do I need to use to help me do that? Times it by 2. Square it, yeah. we want to use a squared and b squared, and what we're going to do is use that to set up a proportion, all right? So what is a squared?
9.
All right, and b squared? 25. Okay, so what we can do now that I'm looking at my surface area ratios is we actually can set up a proportion. So I'm going to set up my 9 over 25. That's my a squared over b squared. My smaller over larger. Where should I put the 378? On the top. Again, because it's the smaller cylinder, 378, over x, the larger cylinder. You see how I set that up? So smaller over larger, and over here, same thing, smaller over larger. All right, so it's important to keep those organized. And from here, it's just cross multiply and solve. So I'm going to cross multiply 9 times x, 9x, and then we're going to multiply 25 times 378, and I get 9450. And then how do you get x by itself? Divide by 9. Divide by 9. Whoops, that wasn't divide by 9. 9450 divided by 9 is 1050, and that's going to be square inches. Okay. All right. Questions on that one? So this is essentially your setup today. Like, this is the work, is proportions. The ratio of surface areas is 16 to 9. So surface areas is a squared to b squared. That's our 16 to 9. We always have to go back to a to b. What's a going to be? 4. And what's b going to be? 3. Okay. So we always have to go back to a to b, but now our job is, if the volume of the smaller pyramid is 297 centimeters cubed, find the volume of the larger pyramid. So what ratio do I have to use if we want to find volume? Cubed. A cubed and b cubed is what we have to use to set up our proportion. So let's see, what is a cubed and b cubed then? 4 times 4 is 16, times 4 is 64. Very good. And 27. Very good. 3 times 3 times 3 is 27. All right, so we get to use this ratio. All right, so I'm going to set this up 64 over 27. So there's my scale factor cubed. All right. Now you'll notice, how is this organized? Big over small, large over small. So how do I set up my other side here? 297 on the bottom. The smaller pyramid is 297. So that's going to go on the bottom, centimeters cubed. And the larger pyramid has to go on the top. So you have to keep it organized, large over small. That is the big key thing there. Large over small. And then we can cross multiply. I always do the x first. So 27 times x is 27x. 64 times 297. 19,008. Weird number. And then divided by 27. That's not divided by 27. Good Lord. All right, 704. All right, and that is centimeters cubed. Yes, it is. Okay. Let's do number 10. Cone A and cone B are similar. The surface area of cone A is 108 millimeters squared, and the surface area of cone B is 147 millimeters squared. What do we have to do with that information? Turn it into a ratio. All right, so 108 millimeters squared over 147 millimeters squared. All right, what should we do with that information? We get, reduce it? You did it the other way. Yeah. Okay. Okay, so this is going to be then 36 over 49. So math bracket? Okay. So again, this is millimeters squared and millimeters squared. So what's that going to give me? Okay. So this is A squared and B squared, let's say, all right? And so then A would be 6 and B would be 7. Are y'all with me with that? 6 times 6 is 36, so the square root is 6. 7 times 7. Okay. All right, always have to go back to A to B. Now, it wants volume. Cube it. So we need A cubed and B cubed in order to set up our ratios. So it says if the volume of cone B is 857.5, find the volume of cone A. All right, well, we got to cube these things. A cubed, 6 times 6 times 6, 216. And B cubed is, oh, my favorite one. 343. 3 plus 4 cubed. Yeah, 343. All right, so I'm going to set that up. So 216 over 343. Those are my volumes cubed. And then it says the volume of cone B. Well, I did A on top and B on bottom. That's important to keep straight. So I want cone B is 857.5, and I'm trying to find the volume of cone A. And how do we solve for A? Cross multiply, yeah. All right, so 343A equals 216 times 857.5. 185,220. And then divided by 343. So this would be 540. It's volume, so that's going to be millimeters cubed. Okay, you have questions for me? So today is all about setting up proportions. I'm going to switch to a delta math problem right now because they are a little bit different, so you can see what to do there.